All right. Once you've established that a function is continuous, now that you know the definition of what it means to be continuous, it's different than having a limit. It's more strict than having a limit. Remember, limit is just left and right. Continuity is left, right, and center, where that hole is filled in. Okay, once you have continuity, there are several different theorems that follow from that. And we will end up abbreviating them all. Today we're going to focus on something called the intermediate value theorem. Okay, and so we call that the IVT. So you'll need to get comfortable. You can cite that just by initials in like explanation. You could say the IVT. Okay, but anytime you cite a theorem, you have to have explicitly said that the theorem was continuous to begin with. That's the hypothesis. Okay, since the function is continuous, then I can use the IVT. Okay, it's like someone trying to invoke one of the rights, like in our Bill of Rights, and they weren't even a citizen of the United States anyway, right? Everything in the Bill of Rights applies as long as you're a citizen. If you're not a citizen, those rights do not apply to you. And so in the same way here, you cannot apply a theorem if it wasn't continuous in the first place. So the first thing you should always do is write down, they'll say, it seems like such a small thing. They'll say, given the continuous function f of x, and then they go right on their merry way. And so your job is the very first thing is you say, since f of x is continuous, and then they're like, great, rubric, check. That person gets the point for that because they started out identifying the continuity. So just kind of start practicing that now. Since it's continuous, then I can use the IVT. So let's talk about what IVT is. All right. Here are the words for IVT. I feel like the picture for IVT is going to make a little bit more sense. The words say a function that is continuous on a closed interval takes on every value between f of a and f of b. In other words, if y is between f of a and f of b, then at some c we're equal to that. Okay, let me try and explain this to you. Okay, when you were born, the way we count age, how old were you? 0, right? Okay, some countries, especially those in Asia, when you're born, you start out at 1. Okay, but the way our Western culture does it, okay, you are now 16, 17, 18. Okay, so you had your birth at 0, you now have 17 years, okay? You lived all of the years in between. You never skipped any of those years, right? You maybe wished you could have skipped like middle school or something, maybe 12, 13, like I wish I could skip that, but you didn't. Your life was continuous. You lived every day, okay, all the way through. It's not like some of the movies or whatever was like it was blank, right? You can't remember anything that didn't seem to exist. That's the intermediate value theorem, okay? If you're given a continuous function that has a beginning, it has to be closed interval, okay? So it has to have a beginning and it has to have an end. That means that by definition of continuity, everything is connected and nothing is skipped from here to here or from here to here. Does that make sense? Okay? There's nothing skipped. There's no gaps. There's nothing missing. Okay, so here's a picture, and then I'm going to have you insert a slide after this to do another picture. All right, this is a continuous function. This function has a specific a. It has a specific b at the end. And all points from a to b are included. Nothing is missing from the domain. But the IVT says nothing's missing from the range either. Okay, the domain is from A to B. Okay, so I want you to think of it that way. It's closed on either end. But the IVT goes farther and says nothing is missing from the range. Okay, the range goes from the lowest value to the highest value. The lowest value is right here, which is not even labeled on my y-axis. Okay, that is the lowest value. The highest value is also not labeled. Okay, there's my high. And what the IVT says is that we guarantee that there's nothing skipped in between those values either. that everything from the low to high, that every single value is accounted for. No value is skipped, no value is missed. Every single value is present in the domain and the range. All right, now insert a blank slide next if you can. You guys know how to do that. Click on the little, like the stack of papers up in the upper right-hand corner and insert, you can duplicate a slide and then blank it out or something. Should be able to insert a blank slide. Does it work? Okay, I've got it. All right, I want you to think of this. Okay, try and copy this picture. Put the axis on there, okay, that's the x-axis. This is the most common use of the IVT. Okay, do we all agree that this is a continuous function? All right, so it's like check boxes, right? Check, it is continuous. Just make the shape. You don't have to do all the labeling, just the x-axis and sort of this shape. Okay, we all agree that it is closed. Okay, and so by virtue of the fact that it is closed, go ahead and mark off the closed, and the domain is going from A closed to B closed, and everything between A and B is present. The domain is a closed domain. All values are present in that. Okay, now I want you to look at the range. What would you estimate to be the lowest value here? Where does the lowest value happen to occur? Okay, I would agree, and I would say that A is the low, so I'm going to agree with you there. Okay, and then where do you say the high is? Is it B? No, there's another high, right? The maximum is probably right about there. Okay, and what it is the IVT guarantees is that everything between that low and high is present. All right, which side of the x-axis is the low on? Underneath the x-axis, okay? Which side of the x-axis is the high on? The top. And if every value is present between the low and the high, the function crossed over what significant place? Has to cross the x-axis to get from the low to the high. So the IVT guarantees if your range begins below the x-axis and ends above the x-axis, if that's your range, then you can prove and say without a shadow of a doubt that your function crossed the x-axis. It's not like it just skipped over it. It had to cross the x-axis. So you don't even need a picture. Okay, I'm going to slide over here. You can maybe fix. If you know that the x-axis is here, and you've been given a high value, and you've been given a low value, and you're told that the function has to be continuous, in order to get from that high value, continuous meaning it's connected, in order for the high value and the low value to be connected somehow, is there any way for them to avoid the x-axis? You can't avoid it. You have to cross it at least once. Could you cross it multiple times? Yeah. Sure. Okay, you could have a function that crosses it once. That would be the most efficient way, but still crossed it once. Or you could have a function that crossed it a couple times. Okay, the IVT guarantees at least one, we call that a root or a zero or a solution, okay, if your range spans below to above the x-axis. Okay, that is guaranteed by the IVT. IVF, something totally different. Okay, the IVT. So if a function is continuous, the IVT guarantees that if the range spans the x-axis, that the function must cross the x-axis. Now, if the range does not span the x-axis, if the entire range is below the x-axis or the entire of the range is above the x-axis, you're not guaranteed to cross the x-axis. But if the range does span it, you're guaranteed that. All right, so let's go back to the existence of the slides, okay? So this is the reason Everything is connected, single, it's unbroken. There's no gaps, there's no removables, there's no breaks, there's no asymptotes. Everything is connected, therefore everything is present. Okay, your life is one continuous lifetime. Okay, so here's how the IVT shows up. They might give you a table. They're not going to give you a graph picture and say, does this graph cross the x-axis? Okay, they're going to give you some sample functions. So let's take a look at, here's some sample values. Notice that you are told specifically that it is continuous. Okay, it's a continuous function. Here's some sample values. Therefore, the question is, does there exist a place in the interval between 0 and 2 where the function might be equal to the number 5? Okay, so they've given you the domain. The domain interval is 0 to 2. Okay, I prefer like this. What's the range interval on that for that domain interval?
3 to 7.
Okay, now no, don't write 7 to 3. Okay, for range, we don't write it in the order given, we write it in the order of low to high. And so the range is 3 to 7. Yeah, but we're only talking about 0 to 2. That's all they want to, yes, I know there's extra, okay, but we're only looking at 0 to 2. So if the range is 3 to 7, are we guaranteed that somewhere in there we would achieve the value of 5? Yes, because 5 is within the range of 3 to 7. That everything from year 3 of your life to year 7 of your life, you had to have lived the 5th year of your life. Okay, it's not possible for you to have skipped that year. So we say since g of x, this is how you would write it, is continuous, and since 5 is between 3 and 7, the IVT guarantees it. Okay, it guarantees the existence of g of r equals 5. That we're guaranteed that somewhere, sometime, you were 5 years old. That would be a sample of how you would write an explanation from a table. Okay, let's look at another one. Okay, here's not a table, here's a function. Here's the function. What are we not told about this function? Well, whether it's continuous or not. So what do you think you have to check? Okay, is it continuous or not? All right, so let's check. What's the left-hand limit? Left-hand limit is 3. What's the right-hand limit? 5. What's the problem? Not continuous. Done. Since k of x isn't continuous, the IVT guarantees nothing. End of story. You're done. You don't have to, if it wasn't continuous, all bets are off. You can't even do anything more. Okay, let's try another one. All right, here's an actual equation. Here's the function defined by, okay, what kind of function is this? Quadratic. What shape does a quadratic make? What do you know about all parabolas? They are continuous. All right, so start. Since f of x is a parabola, it is continuous. All right, phew. Okay, I can move on to the next thing. Now I want to check the range. Okay, I know my domain. My domain is from 0 to 1. Now I want to check the range. Okay, plug in 0. What do you get?
1.
1. Plug in 1. What do you get? Okay, -2. So my range is from, even though I got 1 first, my range is from -2 to 1. And the question is, show that there is a solution. What do they mean by a solution? Okay, a solution is a place where it crossed the x-axis. That's what a solution is. Okay, we also call that a root. We also call that a 0. All right, will there be a 0, aka a root, aka a solution for this function? Yes, because the range spanned both sides of the x-axis. Yeah. It could be. It could be. Okay. So since f of x is continuous, and since f of 1 equaled -2, which was less than 0, or you could say since 0 is between -2 and 1, that would be another way, and f of 0 equaled 1, which is greater than 0, the IVT guarantees a solution, or you could call it a 0, or you could call it a root. Any of those words are all synonymous to each other. But you can say it in your own words, okay? Since the range is on both sides of the x-axis, then we have to have a 0 and a solution on the x-axis. Or since part of the range is below and part of the range is above, it had to have crossed over the x-axis. You can totally say this in your own words. Okay, now here we also have another parabola, but we were not given an interval. So it's our job to find one. So you're going to need to test some sample values to find your own interval. Okay, we know it's continuous because it's a parabola. So I would just say, start making your own table. Easiest to 0, check 0. Okay, when I plug 0 in, I get 1. Then check 1. When I plug 1 in, I get -2. I have now found a range on either side of the x-axis. So my work is done, because you just go until you find 2 values that span the x-axis. Maybe you want to go backwards into negative values. That would be fine too. Okay. We just did the IVT worksheet. These questions were the IVT worksheet that's in Canvas. Okay, so you don't have to do that. There was a second worksheet, that's your homework. All right, but we did the IVT worksheet, so you're done with that. Okay? No, because we did it. There's no book homework. It is just a worksheet. Okay?